The night sky, a tapestry of twinkling wonders, holds a secret. A shadow moves among the stars, unseen by the naked eye but starkly clear to the watchful gaze of telescopes. It is an asteroid, a relic from the dawn of our solar system, and its path is on a collision course with Earth. This is not science fiction, it's a plausible scenario, one that keeps astronomers and planetary defense experts up at night. The universe is a shooting gallery, and our planet is a moving target. While most asteroids are harmless, some are large enough to pose an existential threat. The question is not if, but when, we will face this cosmic challenge. We have a choice: to be caught unprepared or to rise to the occasion, harnessing our knowledge and technology to protect our planet and our future. Imagine this. Astronomers around the world sound the alarm. An asteroid roughly the size of a city block has been detected on a trajectory that intersects with Earth's orbit. The impact is projected in 14 years. Panic grips the globe. The news dominates headlines, social media erupts, and governments scramble to respond. The world holds its breath, caught in the grip of a countdown that feels both agonizingly slow and terrifyingly fast. 14 years may seem like a long time, but in the grand scheme of things, it's a blink of an eye, especially when the fate of humanity hangs in the balance. But it's also enough time to act, to mobilize our resources, and to mount a defense against this celestial adversary. Thankfully, we are not going into this fight blind. For decades, NASA and other space agencies around the world have been scanning the skies, diligently tracking near-Earth objects like asteroids and comets. Using powerful telescopes both on the ground and in space, astronomers meticulously map the trajectories of these celestial wanderers. Sophisticated computer algorithms crunch the numbers, calculating orbits and identifying potential threats.
This global network of cosmic watchdogs is our first line of defense, providing early warning of any potential impactors. The more time we have, the better our chances of successfully deflecting an asteroid. Knowledge, as they say, is power.
Once an asteroid is discovered, the next step is to assess the threat it poses. This involves determining its size, mass, composition, and most importantly, its trajectory. The size of an asteroid is crucial because it dictates its potential impact energy. Even a relatively small asteroid, if it struck Earth, could release the equivalent energy of thousands of atomic bombs.
Astronomers use a variety of techniques to study asteroids, including radar observations, spectroscopy, and even sending spacecraft for close-up reconnaissance. The more we know about an asteroid, the better equipped we are to devise a plan to deflect it.
The consequences of an asteroid impact are grim. Depending on the size and speed of the asteroid, the impact could trigger widespread devastation, including massive earthquakes, tsunamis that could inundate coastal cities, and wildfires that could rage for months.
The impact would also eject massive amounts of dust and debris into the atmosphere, blocking out the sun and plunging the planet into a prolonged period of darkness and cold. This impact winter could disrupt agriculture and ecosystems around the world.
In short, an asteroid impact would be a cataclysmic event, potentially threatening the very survival of our species. However, it's important to remember that this is a preventable disaster. We have the technology and increasingly, we have the foresight to avert such a catastrophe.
Section 6, Averting Armageddon. So how do we stop an asteroid? Thankfully, NASA has a few ideas.
One proposed method is the kinetic impactor, essentially a high-speed spacecraft that would slam into the asteroid, nudging it off course. Another idea is the gravity tractor, which would use the gravitational pull of a spacecraft to slowly tug the asteroid away from Earth over time.
In extreme cases, we might even have to consider a nuclear detonation. While controversial, a carefully orchestrated nuclear blast could vaporize part of the asteroid's surface, creating a jet of material that would act like a rocket engine, pushing it off course. Section 7. A united front for planetary defense. Protecting our planet from asteroid impacts is not just the responsibility of one nation, it's a global imperative.
International collaboration is essential for sharing resources, coordinating efforts, and ensuring a swift and effective response. Just as nations came together to address the threat of nuclear war during the Cold War, we must now unite to confront this shared cosmic threat. The fate of humanity could very well depend on it.
By working together, sharing data, and pooling our resources, we can develop a robust planetary defense system capable of protecting our planet for generations to come. Section 8. Preparing for the unthinkable. While NASA and other space agencies are working tirelessly to address the asteroid threat, it's also crucial for individuals and communities to be prepared.
This involves raising public awareness about the risks of asteroid impacts and developing emergency preparedness plans. Just as we have drills for earthquakes, fires, and other natural disasters, we should also have protocols in place for an asteroid impact.
This could include identifying safe havens, stockpiling supplies, and developing communication systems that would function in the event of a major disaster.
Section 9. Our future among the stars. The threat of an asteroid impact is a stark reminder of our vulnerability in the vastness of space. However, it is also an opportunity to come together as a global community and to embrace the challenges and possibilities of space exploration. By investing in science, technology, and international cooperation, we can not only protect our planet from this cosmic threat, but also pave the way for a future where humanity becomes a truly spacefaring civilization. To learn more about NASA's efforts to track and deflect asteroids, please visit insert NASA website link here.